So the goal for today of lesson 8 is to sketch graphs to represent situations. So I think it's a pretty quick and easy lesson. It does kind of refresh our memory from before break because we kind of already did this. My first hour did not have time to do the practice in class. Maybe you guys will, but either way, it seems easy enough that you could do it for homework. And it's been available since before break, so I've had plenty of people say that, they got an 80% or higher without even having learned the lesson yet, which is great. Probably really doable, and if it's not, you can probably look up on YouTube the title of the lesson and get something that will help you. So just keep that in mind. I'm recording right now. Puzzle Piece is in Schoology in this week's folder. You do have a quiz this Friday over all of Unit 4 so far, and what we'll get through in the next few days, just so you know. And then the rest of the assessments for this semester are always in the slides, but for the rest of the semester, they're already listed. I did have to move up the Unit 4 test a day, so that has been changed, but otherwise everything has been posted since before break. So questions on that? All right, so just make sure we're aware. There's really not that much time, including this week. There's 3 weeks, and then you take your finals on that Monday and Tuesday, and then it's winter break. So if you're planning on being absent for finals, just know that they put in a 0 for your final, which is 10% of your grade, and then they pull you to take it like in January. So if you're like going to be absent and you're also not coming back to the school, then sorry, I don't know what to tell you. Like that's how they do it. If you're not here for finals, they put in a 0. And if you're still enrolled second semester, they just pull you second semester to take it. So keep that in mind. Questions? All right. So for the warm up, raise your hand, and it doesn't have to be like a group consensus. You could disagree with your group, but raise your hand if you have a reason that graph A doesn't belong. Wrigley? So no curve. Anyone disagree with that? Do you disagree? You think there is a curve? Okay, so there's no curve in that one. The other ones do have at least one curve. Use the math vocabulary that we learned prior to break. How can you also describe graph A? Anyone? It is straight, but more mathematical. It is linear, but what I was looking for is constant. So it's going at a constant rate. At the same, and we're talking about time compared to temperature. So no matter how much time passes, the temperature stays the same. What could this be an example of? I don't know. That I don't know. Maybe. What else has a constant temperature? A fridge. Did you say a freezer? Or did you say Phoenix? Yeah. Did you say a freezer? Okay, that also has a constant temperature. I thought you said Phoenix. That would. So yeah, good observation. Now raise your hand if you can tell me why B does not belong. Anyone? Only one that curves up. Anyone disagree with that? So this one does go up. So it's the only one that goes up one time. How else can you describe that with like the math vocab we learned? It increases, then decreases. Wouldn't you say that's true? So increases, then decreases. Any other math words you can think of? All right, well, here's one that the book says that you guys should also be acquainted with. It's the only one that has one maximum. So it has just the one maximum, is another reason it doesn't belong. Who can give me a reason why C doesn't belong? Brian?
Because it's the only stuff that goes through that except only.
Okay, only one that touches the x-axis. What do we call that? Like where it touches the x-axis? X-intercept. So it's also the only one with x-intercept. Any other reason it doesn't belong?
It only has one, minimum.
Good, it only has one minimum. Where would the minimum be? Describe it to me. Perfect. The lowest point of the graph. You could also say it's the only one that decreases one. Basically the opposite. Who can give me a reason why D doesn't belong? Okay, I think I heard that it's squiggly. Now let's convert that to like math vocab. Does it have maximum and minimums? Yeah, it has both. So we could say it has multiple. Maxima is how they pluralize it. And minima. Multiple. And there's multiple because it looks like they are at the same height, like one isn't bigger than the other. Same with the minimums. One isn't lower than the other, otherwise the lowest one would be your minimum. So it looks like there's multiple. Any other reasons? All right, you could say it increases and decreases multiple times if you want to use those words, but yeah. So I think you've kind of caught on by now. Usually there's a reason why every single one doesn't belong. All right, and finding that is a good observation. Now for what's actually on your paper, we're gonna divide and conquer this, but let's see what's going on first. A flag ceremony is held at a 4th of July event. The height of the flag is a function of time. Just a side note, function of time, we've been talking about function notation a lot, which is this, f of x. How do I say this? I just said it, but like, how do I say it? F of x, so it's function of x. So when it says function of something, guess what that something is? X, or in other words, your input or your independent variable, all of that stuff. Just trying to refresh your memory. Just a little tip for you, if you need to figure out which is independent or which is dependent, or your X or your Y. So function of time, that's why time is on the x-axis. It usually always is if it's time. So we have some graphs that are each a possible representation of the function of them doing something with the flag. We're going to divide and conquer this. So table 1, you will describe A. So here's the rest of the instructions. For each graph assigned to you, explain what it tells us about the flag and decide as a group if it appears to be realistic or not. So table 1, you'll do A. Table 2, you'll do B. Table 3, you'll do C. 4, B. 5, E. Table 6, you'll do F. Table 7, I'll let you pick which one do you want to do table 7. Here, I'll remind you guys. Hopefully you guys remember your groups, but if not, ask me. That's Peyton, Alyssa, Aiden, and Sierra. So that group, which one? D. And then table 8, I'll let you pick, don't pick B though. Which one, B? All right, so now you know what you're assigned. You will, as a group, come to a consensus, answer number 1 for your particular graph. And then we'll all share our thoughts. So make sure everyone in your group knows the answer, because you don't know who the reporter is gonna be yet. Sure you all agree, write it down so that you remember. We'll share in about, I don't know, 2 minutes. I don't think it takes that long. All right, so.
That is hard.
What would be going on? Graph? Yeah, write down what the other groups say as you go over them. That's part of your zone. You just divide it up. So table 1, your reporter, what would this say about your graph? So constantly being raised, yes, I would say raised at constant rate, which is the same thing you said. But yeah, it's being raised at a constant rate. Do you guys think that that is realistic, class? Yes, do you think that their assumption about the flag is correct? Yes, I agree. We don't know what increment it is for the time. It could be seconds, it could be minutes, it could be hours, I guess, but it's probably not hours, but it's raising it at a constant rate for 6 hours, I don't know. But yeah, based on what we're given, it does seem reasonable, so I would say yes. It is realistic. Table 2, what would graph B tell us about the flag? Well, the graph is moving, but the flag so would it be raised at all? How about table 8? Because table 8 has this too. Table 8, would graph B be raised at all? Like the flag, I mean. So the flag not raised or lowered. Yep, it stays at a constant height. We don't know what the height is. Or I guess we do. We don't know what the 3 is, if it's meters, feet, whatever. Probably not feet, but it's not raised or lowered throughout the entire time. Is that reasonable? Yes. Good. Table 3, what would graph C tell us about the flag? So not raised at a constant rate. Class, do you agree with that? Yeah, if it was a constant rate, it would be a straight line. It has a curve in it. So not raised at constant rate. What might have happened like here? So it could have just been left alone here. And then they decided to raise it higher. What else could have happened? My first hour said it could have also been stuck right there. Who knows? Is that reasonable? Yeah, so we'll also say that it is realistic. Good. Table 4, what you guys put for graph D? Okay, so constantly move up and down. Table 7, what might someone want to do that for things? Or what could have happened? What table 7 say? Just why would it be moving up and down? Do you think that they like what could have happened in the real world? Guys, be respectful. Still coming? So why might it be moved up and down like constantly? What do you think might have happened? Sometimes the wind maybe? Constantly raising it and lowering it. Any other reasons, Scott?
Cause, the slightly lower unless it's.
Okay, so maybe you're thinking that for the time that it's talking about days, like 1 day, 2 days, 3 days, is that what you're saying? Okay, what we said first hours, maybe like some kid is like playing with it. Like going up and down, raising the flag. Who knows? But yeah, would that be realistic, you think? Sure. Not a definite yes, but sure. Now table 5, what would graph E tell us about the flag? Constantly move. Anything else to add about that? Maybe every hour it's raised a little bit, if this is hours. Constantly moved in what direction? Upward. And it kind of just looks like they're taking little breaks. Like pulling it, stopping for a second, pulling it, stopping for a second. So is that reasonable? All right, last table 6, what would graph F tell us about the flag? So raise up, then down, and then what? Then not at all. So then I'll just put then at a constant. So it was raised up, then down, then at a constant height, so then it stops being raised. Is that reasonable? Yeah. Now, I agree. I think that they are all possible. The book picked for some to be more realistic than others. But either way, at the end of the day, as long as there's no like negative height or negative time, then I think that they're all realistic and possible. But here's what the book says, and you can agree or disagree with them. So they said that graph E, stop talking over me. They said that graph E seems to be the most realistic. That graph B and D are the least realistic. And graphs A, C, and F are possible, but unlikely that the flag starts out being on the ground. Right? Because where would zero height be? The ground. So usually if you're raising a flag, it's already up. And they did say that they're raising it, so that's why they said B might be unlikely. And then E is the most likely because usually when you pull a flag up, you have to pull it. So you like take little breaks in between. So questions on that activity? All right, almost done. So now look at number 2, which is here, this graph that is also on your paper. This is another graph that relates time and height. Discuss in your groups if this graph can represent the time and height of the flag. That's in your group. So raise your hand if your group said yes, it could represent the flag. All right, Brian's group, why did you think that? Okay, so he said the flag being raised at a certain time. Anyone disagree? Technically, you all should, because they were the only group that raised their hands. So who said that this is not a function of time and height of the flag? Raise your hand. That would be everyone else. Okay, why did you think that, Jalen's group? So they said because you can't lift the flag that fast, maybe? Any other reasons? Yes? Still one important one that I haven't heard yet, so anyone know? Yes, time should start at 0. It doesn't just jump to 3. Especially if time is representing like time after they started raising it, time should start at 0. Or whatever increment they say, but there's no way like it just starts at 3 and ends at 3 when we're talking about time. Now, is this a function? Yes or no? Okay, I heard one person. So why do you think it is not a function, Julian? Class, how do you know if something is a function or not? Not because it starts at 0. Okay, so to repeat that louder so you can all hear, for it to be a function, each x has to have exactly 1 y. But look at what we have here. This x of 3 has a bunch of different y's, and I'll just show you some of them. Here's 3, 1. Here's 3, 2. Here's 3, 3, and like every fraction in between. So it is not a function because there is a repeating x. There's another way that you could tell, and I want you to write this down somewhere. And we call it the vertical line test. So you could just check for any x's that repeat. Or you could do a vertical line test if you're given a graph. And what that test says is that if I draw a vertical line through the graph and it touches at multiple parts of the same vertical line, so like here, here, for this graph, then it's not a function. So then going to these examples, is a function? Yeah, because I could draw vertical lines throughout the whole graph and it only touches once on each line, right? Is B a function? Yes, same thing. It touches on each vertical line just once. Are there C and D functions? Yeah, the same thing. I could do the vertical line test. They would touch just once on each vertical line. What about on A through F for our example? Are any of these not functions? Would they all pass the vertical line test?
Yes.
Yes. Here's an example of something that wouldn't, or like if I had a graph that looked like this. Right, if I draw a vertical line through this graph, it fails here and here. Because it touches the graph twice on the same vertical line. Same if you have a graph that, I don't know, looks like a square. The vertical line test would have it fail because it touches the line twice. That makes it not a function. So questions on that? All right, I wouldn't just pack up and wait for the bell to ring. I would do at least a few problems on my practice. But that is all for this lesson.